For our first wedge, we decided to pick efficiency transport. It increases automobile fuel efficiency. 2 billion cars projected in 2050. Therefore, doubling the efficiency of all world's cars from 30 miles per gallon to 60 miles per gallon. The next wedge we chose was efficiency buildings. It increases the insulation, furnace, and lighting efficiency, using the best available technology in all new and existing buildings.
Our third wedge was efficiency electricity. It increases efficiency of power generation, raising plant efficiency from 40% to 60%. The next wedge is CCS electricity. 90% of CO2 from fossil fuel power plants captured, then stored underground. It injects a volume of CO2 every year equal to the volume of oil extracted.
Our next energy source was CCS synfuels. It captures and stores the CO2 emitted during the synfuel production from coal. Using CCS at 180 large synfuel plants would be one way we can use the wedge. The emissions still would only break even with gasoline, though. The sixth wedge we use is wind electricity. Wind displaces coal-based through electricity 10 times the current capacity. Using an area equal to 3% of the U.S. land area for wind farms. Not in my backyard. Dude, these things look so
The second to last one was solar and electricity. Solar PV displaces coal-based electricity up to 100 times the current capacity, using the equivalent of 100 times 200 km PV array, which is also PV cell materials. The last wedge that we chose was biofuels. Biomass fuels from plantations replace petroleum fuels, scaling up world's ethane production by a factor of 12. Biodiversity competing land use.
And now Block 2's wedges. The first wedge we chose was efficiency transport, because transportation needs to be more efficient. One wedge could come from doubling the efficiency of all the world's cars from 30 to 60 miles per gallon, which would mean we spend less money on gas, we use less gas, and therefore emit less pollution. The second wedge we chose was efficiency buildings. This would increase insulation, furnace, and lighting efficiency, using the best available technology in all new and existing buildings. This would increase electricity efficiency, which means we would waste less energy. The next wedge we chose was forest storage. It would be carbon stored in new forests, which would halt deforestation in 50 years. The next wedge we chose was efficiency electricity. This would increase the electricity of power plants, raising plant efficiency from 40 to 60%. The next wedge we chose was carbon capture and storage synfuels. This would capture and store CO2 emitted during synfuels production from coal. The next wedge we chose was wind electricity. This would be wind displacing coal-based electricity, but it would use an area equal to 3% of the U.S. land area for wind farms. The next wedge we chose was biofuels. Biomass fuels from plantations would replace petroleum fuels, which would lead us to using less petroleum. The last wedge we chose was solar electricity. Solar PV displaces coal-based electricity, which would mean less use of coal and fossil fuels and less pollution. And now for our group's final combined wedges. For our group's final wedge design, we chose efficiency transport to increase automobile fuel efficiency, efficiency buildings to increase insulation, furnace, lighting efficiency, CCS electricity, which is carbon capture and storage electricity, efficiency electricity to make electricity more efficient, carbon capture and storage synfuels, wind electricity, biofuels, and solar electricity. We didn't have very many different wedges, so we just compromised the one and combined them. And that is our final finished wedge design.